Welcome to this explainer. Today, we're diving straight into the Minto Garden project. It's an absolutely fascinating case study in using step-by-step landscape design to overcome some pretty severe environmental constraints, ultimately turning a volatile site into a completely self-sustaining ecosystem. If you follow landscape architecture or advanced horticulture, the real intro here is the precise, methodical implementation used to solve these complex ecological problems. But before we look at any of the specific flora, we have to ask the critical question that drove this entire project from day one. How do you design a landscape that survives wildly fluctuating seasonal extremes? It's a really fascinating biological puzzle. Most plants are evolutionarily specialized for either drought or flood conditions, right? A succulent thrives in the dry heat but rots in standing water, while a wetland plant loves the spring floods but turns to dust by August. Designing a space that won't drown in the spring, but also won't wither and die in the peak of summer, requires some serious horticultural engineering. So, here's our agenda for today. We'll quickly assess the extreme environmental challenges, look at preserving the ecosystem, select our resilient native species, plan for year-round color, and finally, visualize the final garden. All right, starting with Section 1, Extreme Environmental Challenges, Battling the Elements. The source material highlights a really stark juxtaposition here. The chosen flora absolutely must be able to thrive in extreme wet conditions during the spring. We are talking about highly water-tolerant roots. What's surprising to a lot of people is that in standard residential gardens, spring floods don't usually kill plants by washing them away, they kill them by literally suffocating the roots, leading to immediate root rot. But then, fast forward just a few months, and those exact same plants have to survive the intense, scorching heat of the late summer. It's an incredibly demanding environment that requires highly adaptable root structures to manage these massive moisture fluctuations. Moving on to Section 2, Preserving the Ecosystem, Protecting What's There. So, the designers definitely weren't working with a blank slate, and they actively chose not to clear-cut the site. It was a top priority to build around the existing natural features. The source specifically notes the importance of protecting the existing dogwood and bulrush, as well as this massive willow tree. Preserving a mature willow or dogwood is absolutely crucial from a practical standpoint. Why? Because their huge, established root systems play a vital role in stabilizing the soil against those exact same spring floods we just talked about. The goal was to ensure the new design didn't disturb the local ecosystem that was already doing the heavy lifting of holding the terrain together. Which brings us to Section 3, Resilient Native Species, the Strategic Steps. To actually bridge the gap between extreme weather and ecological preservation, the designers followed a super clear three-part methodology. Step 1, assess those severe weather extremes. Step 2, protect the existing flora. And finally, Step 3, carefully select resilient native species specifically suited to combat the elements. This step-by-step implementation is literally the linchpin that makes the whole project successful. By relying on the evolutionary traits and genetic adaptations of native plants, the designers effectively engineer a self-sustaining system. This massively reduces the need for artificial irrigation during droughts or chemical interventions later on, simply because the plants are already inherently equipped to handle the local climate swings while naturally supporting native pollinators. You can see this strategy applied directly with the pairing of the blue flag iris and the blazing star. The designers specifically combined the striking violet blue of the iris, which blooms in June and July, with the vibrant purple of the blazing star. And from the data, we know the blazing star grows up to 5 feet tall. What is so fascinating about implementing a perennial of that height is that it acts as a highly effective, natural structural windbreak for the more delicate plants around it. This pair perfectly attracts summer pollinators while creating a towering, resilient wall of color. Then, as we transition into the late summer and fall, they introduce this brilliant yellow palette. This is achieved by pairing the black-eyed Susan with the goldenrod. According to the project's plant data, they used 22 black-eyed Susans and 12 goldenrods. This pairing injects gorgeous, resilient color right into the hottest, driest parts of the year. Interestingly, goldenrod is often falsely blamed for causing seasonal hay fever, which is actually caused by ragweed blooming at the exact same time. Because of that myth, goldenrod is a highly underutilized plant, but it is a brilliant, completely drought-resistant choice that thrives when most other gardens are just starting to wilt. Let's look at Section 4, Year-Round Color, Data Meets Design. When we look at the spatial planning metrics, the staggered structural heights become really clear. Meticulous planning went into ensuring year-round visual texture here. Check out the range extracted from the blueprints.
They're using 17 sweet woodruff plants as a tiny, half-foot spring-blooming ground cover. But then, they deliberately contrast that low layer with massive structural anchors, like the Rose of Sharon and the Spice Bush, which tower anywhere from 8 to 12 feet high. This creates incredible vertical depth in the garden space, drawing your eye upward and making the whole area feel significantly larger and way more dynamic.
Now, with all those towering plants and different shrubs, visual cohesion becomes your next big challenge. To unify those varying heights, they planned a massive installation of exactly 116 periwinkle plants. This specific perennial blooms in the fall, spring, and summer, creating a sweeping, unified carpet of blue, purple, and white across 3 full seasons. A really common mistake in everyday landscaping is focusing solely on the big vertical showpieces and totally ignoring the ground level. Utilizing a massive unified ground cover like this is exactly what makes a garden look professionally designed and intentionally anchored rather than just a cluttered collection of random plants. Finally, Section 5, Visualizing the Final Garden, the Blueprint to Reality. By mapping out the precise spatial planning in this cross-section blueprint, we can actually see how the dense, varied heights of the flora naturally slope and frame the landscape. It's definitely not just a flat, arbitrary line of plants. The taller shrubs and those vibrant purple spikes of the blazing star we mentioned are deliberately positioned to frame the central stone platform, creating a natural flow and visual boundary against the wooden fence in the background. It is a highly calculated layering process. When we visualize this layout in 3 dimensions, the step-by-step strategy truly comes together. Bringing back our ecosystem preservation rule, you can see how beautifully the massive existing willow tree hangs down, physically framing the newly implemented pollinator-friendly landscape right beneath it. Instead of fighting existing nature, the design actively embraces it, instantly giving the newly planted garden an immediate sense of maturity, scale, and permanence. From this angle, looking toward the water, the logic behind those staggered structural heights makes complete sense. The intense purples, the bright yellows, and the soft whites of the resilient native species truly pop against that wooden fence. The meticulous layering ensures that no plant hides another, maximizing sunlight exposure for every single species. This really highlights the vital final step of implementation, placing the right native plant at the exact correct elevation to maximize both survival and aesthetics. And here is the final, holistic vision of the complete Minto garden project. This wide shot represents a perfect synthesis of the entire design process. By assessing the severe extremes of the environment, preserving the mature root systems already on site, and engineering a layered native defense, the result is a living, breathing ecosystem designed entirely by data. It proves that incredibly practical, highly technical climate solutions can also be breathtakingly beautiful. As weather patterns become more extreme and unpredictable everywhere, this explainer leaves us with one really provocative thought to take away. Is the Minto garden just a beautiful backyard project, or is it actually the ultimate blueprint for the future of resilient home landscaping? When the climate continuously challenges us, perhaps the absolute best defense is a beautifully structured, highly calculated native offense. Thank you so much for joining me to explore the engineering behind this incredible design.